it's a moment of silence and remembrance of our God. Fatiha. Can you read the reading there and the writing there?
Can see.
Yes.
Okay. Okay, today we want to continue we have started the analysis on the strain analysis, right? Remember last week we talked about what are strain. Strain is talking about how the deformation. How do we talk about the deformation? Axial strain, they can elongate and become shortened, become longer, become shortened. So they become a positive strain, negative strain. And the deformation or the elongation over the original length, no unit. And then we have about the shear strain, about the shape of that one become shifted to the left or to the right, or being twisted, or the square one become like a rhombus or like a kite, being twisted. So that's the effect. So that are talking about the angle. How the angle deform. And usually the angle is less than 1 degree, maybe 0.1 degree. We're talking about that. We're talking about metal. Cannot see by our eyes. How the deformation change, that's gamma. On the shearing part. On the normal part, due to sigma, elongate and shorten. Elongate or shorten. And the shape, that one become elongate or shorten. That's all. Become bigger or smaller. But the twisting part, the shear stress will become angle. The angle is not square anymore. And rotating on the left to the right. So that's the main thing we have to understand. How the shape change due to normal stress and the shear stress. Are you with me, guys?
Yes, doctor.
And both are no unit. The angle change to radian. Very small angle change to radian. That's why very small angle. Okay, now when we know when we do the analysis, we know about two things. What is that? In x direction, y direction, that we know EX, let's say the value is 100 microstrain, EY is equal to negative 200 microstrain. If that is the case, that is the original shape. The final shape is that one become bigger and that one becomes smaller. So when there's no gamma, that means the gamma is 0. That means, so the new shape will be like that. So that is EX, that is EY. Become smaller, become bigger. Basic understanding that in X and Y direction. Okay, clear, guys?
Clear.
Clear. Okay, now, what if we have that one? We have a gamma XY. It's not gamma XY, okay? Gamma XY over 2. Let's say the value is minus 200 microstrain. So how do we draw that in XY? Again, that is the original shape must be there. And then positive there, negative there. And the angle negative become bigger or smaller?
Smaller. Negative bigger.
Positive smaller, right? So this angle, we're not talking about so many points there. This angle between X and Y. And between X and Y, we're talking about that angle because the other one become the other side. If this become bigger, this becomes smaller. If this becomes smaller, this becomes bigger. So we have to understand that. One is bigger, one is positive, one is negative. So this negative here is talking about that angle. Okay, this has become bigger. So bigger a little bit from 90 degrees because the original one is 90 degrees there. So coming out there. coming out until that point, and coming out until that point. Only then we draw the parallel line with that. Parallel line with that, we got line that. And then parallel line like that, we got a line like that. So this is how you draw. It's better for you to use different kind of pen. Different color of pen to show that the original and the new one. And then write the value there. EX equal to positive 100 microstrain. EY equal to minus 200 microstrain. And then here, gamma XY over 2 is equal to negative 200 there. Are you with me, guys? So these are the basic method how to draw that one. Okay. Now we want to go back a little bit. How do we got this one? How do we got that one? How do we got that value? How do we got that value? In theoretical, the measurement is no problem. What is EX? EX is delta X over LX. That is theoretical. Same with that one. What is EY that one? Delta X over LY. Delta Y over LY. No problem. And then gamma is Y over 2 is the angle. Tangent gamma SY is equal to gamma SY. So how's the shape changing that one? That one. That is gamma here. Gamma SY. Yeah? If we draw that one, the other side, a little bit there, a little bit here, half here, half here. This is full here, no here. This is gamma SY over 2, this is gamma SY over 2. So, this is gamma SY. Tangent gamma is equal to gamma. Tangent gamma is equal to A over B. Tangent gamma SY is equal to A over B. It's equal to tangent gamma. It's A here, B here. Are you with me now?
Yes.
But this is all theoretical. These are theory. A formula only. In real life, how do you measure it? How do we measure EX then? How do we measure EX then? This direction of X there, direction Y there, how do we measure strain in that direction? So in practical, how do you do that? We use strain gauge. We use what? What do we use?
Strain gauge.
Strain gauge or strain rosette, the name of the things. The measurement device is strain gauge or strain rosette. If you look in your books, I send you the picture already in the books, in the picture of the strain gauge. If you look at if you see that, the picture like that. You see that?
Can see.
Yeah. There's a picture, that one. What is that actually? What is that actually made of? Yeah? I put a strain gauge in that direction. Let's say in A direction there. And then I put a strain gauge in that direction there. Yeah? This is X direction. And then I put a strain gauge in Y direction there. Got the value there. This is Y direction. So I put the strain gauge, I put the rosette, I glue it. This device here, I glue it to the surface of the metal. I glue it in that direction. Let's say this is 40 degrees from X. I put the strain gauge. So I got the value there. So what is this? Strain gauge is measurement of normal strain only. Strain gauge is device to measure the normal strain. EX. EX give the value. And then here, EA at an angle 40 degrees from X. You got a value. And then EY there, which is 90 degrees from X. I got a value. What do I use that one? Strain gauge. It's a device to measure normal strain only, not the shear strain. Strain gauge measure normal strain only. Strain rosette measure normal strain only, normal strain E only, not gamma. How does it work? When you are in Form 5, when you are in Year 1 university, you are satisfied by them memorizing the strain gauge. Measure the normal strain only. And then you, okay, finish. Right? What else should you ask about this strain gauge? You must create asking. Asking is thinking. What else should you ask about this strain gauge for you to understand? Everybody, please. I don't want you to say what?
Sensor. It is a sensor.
Yes, it is a sensor. I want you to create a question to understand strain gauge. Give me some question.
How does it work?
That's the main thing. This is engineer. How does it work? If I give you just a measurement the strain and you satisfy, you are just a typical Form 5 student, typical high school student, doesn't want to dig. You yourself have to dig. The main question is, how does it work? That's how there. Why, what, when, how. Those are questions for you to dig. Yeah, how does it work? To answer that one, what do we have here in the strain gauge here? Strain gauge is nothing, just a wire, a small wire. Yeah, a small wire in that line. That one. If I put that line, it's just a small wire. If I put that line, just small wire, that line. If I put that line, just small wire, that line. But to make it easy to do the work, what do? We bend it like this. This one, we bend it like this. And then we bend it like that. And then bend it again. Bend straight there, bend it a bit, straight there, bend again, straight there, bend it again, straight there. So, disregard about the end there, but most of the wire are in that line, right? That line, that line, that line, that line, all that are in straight line, that direction, right? Are you with me?
Yes. Yeah.
Yeah, most of the wire are in that line. Just at the bending part at the end there. Bending part. But most of the wire here are all in that line. Same thing here. You put a string like that. Most of the wire are in that line. So it's just a wire. And then we put a cap at the back where we can glue it to something. But it's not connecting to the, there must be a non-conducting electricity. There must be a glue somewhere at the back. Because wire, if we connect to the metal, so the current go to the metal, right? So there must be some paper bag, whatever it is, at the back there. So the current is not going to the metal. So put a current there and a current there. So it's just a current. Put a voltage here, put a voltage there, put a current and a battery there, and a system there, computer. So if I put current here, the current slow there, and I can measure the voltage or the ampere, whatever it is. Correct, guys?
Okay, correct.
Hello?
Yes.
Yes. What if I put there and this is being stretched? What happened to the wire? When
Elongate.
the beam is being stretched in that direction, what happened to the wire too? Because the wire is being glued to the beam. What happened to the wire?
Extend.
The wire extend. Okay? What are other phenomena when things extend that way? What happened to the diameter?
The diameter smaller.
Increase.
The diameter decrease. When it's elongate in that direction, the diameter decrease. What happened to the resistance in electricity?
Increased.
Yes. The concept of how it works is about the resistance. When this is being stretched that way, the wire size becomes smaller and the resistance increase. So the resistance increase when things. So when you and then you calibrate back the ohm, the resistance that one, the ohm that one, the resistance increase when this load is increased. When we're not talking about the load is making that one. The elongation increase. When the elongation increase, the resistance increase. When the resistance increase, the voltage also changing. The ampere is also changing, right?
Yes.
Okay. The changing of that voltage or the ampere, you can read the ampere or you can read the voltage. The changing with that, we calibrate back with the ampere with the ohm, and then we calibrate back with the elongation, and then we calibrate back with the strain. That's how the strain gauge meter is working. It's just we calibrate. If you are reading the voltage, we calibrate the voltage is changing with this with the resistance, and then with the elongation changing with that one. The changing of that one we calibrate back with the strain. Are you with me?
Yes.
Show me where this one work. Beside knowing this one, where is the other thing like this work? You see every day. Tell me. Hello guys, you see this every day. I want you to understand it. If not, you are just blank to your head, gone. Where is this calibration works every day? You see every day, where? Come on guys. Jangan jadi dungu.
No idea.
You go to the supermarket, you buy thing and you wait something. The scale that you use in the supermarket. Or you wait in the morning, you wait your scale. The digital scale. How does it work there? Exactly like this. They put, when you weigh thing, measure timbang, the scale, timbang dekat pasar tu, the electronic scale that one, 5.716 kilogram. How do they know kilogram that one? Hello, how do they know kilogram? They are all talking about
High
the strain
difference.
gauge. They are all talking about when you put weight, the gauge is being compressed or pulled. So the resistance become bigger or smaller. When being pulled that one, the size become smaller. And then the resistance become bigger, and then you change, you calibrate back with the kilogram with voltage. Are you with me, guys?
Yes.
Yes, doctor.
You see this every day, but you never ask, right? Do you think that scale they have kilogram there? It's all battery. Are you with me, guys?
Yes, baru faham.
Ah, this is how the strain gauge is working. Exactly as your scale. There must be strain gauge. On your scale, there must be strain gauge. And then the current is going there, and the change in resistance, that one calibrate back with the kilogram. So this one we calibrate back with the strain. Are you with me?
Yes.
Ah, nampak tak? How is your head is not learning anything? You see the scale, but you never ask yourself, how does it work? Nampak tak? Saya nak beritahu yang kamu tu tak gerti fikir. Itu saja. Kalau kamu pandai fikir, you will always ask yourself, how does it work? Ini yang saya nak tekankan. This is what I'm telling you why you go to university. To develop you, know how to think. Know how to think is not know everything. Know how to ask. Are you with me?
Yes.
Asking is thinking. How does it work? It's asking. And then from that, you can move on. Without start with asking, you are not going anywhere. You just receiving all the information from your lecturer, and then you never ask the note. You never ask yourself about the note. You never ask about it. You just try to memorize everything there. That's why you are dummies. High school is for dummies. High school is for follower. That's why the technician are follower, the nurse are follower. Not the doctor, not the engineer, not the officer. Or the clerk are follower. Are you with me? Change your mindset to keep asking. Keep asking, what is that? When you see things, ask. When you see the note, ask. When you read the theory, ask. When you see the picture, ask. From that, you will develop your thinking skill more and more. The first step is what?
Ask.
Ask. Even though I give you the note, you must ask yourself, what is the note there? This is for what? This is for what? Or this is to relate with that? This is for what? And this is how you do your learning. This is how you do your learning. When you finish the class, you must do the learning by asking. Are you with me?
Yes.
Okay. So how now we know the strain gauge. We put in the y direction on the surface of the beam, we can get a strain in the y direction. This is just a symbol. Put in x direction, we got a strain in x direction. We put a strain in 30 degrees, so we got EA. Sorry, let's say we put EA there, 300 microstrain. Let's say. And then EB here we got minus 100 microstrain. And then EC here we got minus 400 microstrain. Let's say this is the value. So we decide by ourselves. What direction is EA here?
X.
X direction.
X. You must decide because normal horizontal is X, right?
Yes.
So EC is Y. Are you with me?
Yes.
Okay. I got a value. I put 3 strain gauge there. I got a value there. I know my EX. EX is 300 microstrain. I know my EY. EY is minus 400 microstrip. So I have to know what is gamma XY over 2. To do an analysis, I have to find this first, correct?
Yes.
So how do I find this one? I don't have any device to measure the angle. I have device to measure the normal strain only. So what do? I use these things here to solve this one. How do I solve this one? I use the old equation. What are the old equation that we know? Ex dot or E theta is equal to, please help me,
EX
EX
plus EY over 2
over 2
plus EX
plus EX minus EY over 2
plus
cos 2 theta plus
plus
gamma XY over 2
sine 2 theta.
sin 2 theta. Okay, now look at this carefully. Everybody of you. This value, that value I know. I want to find this. Now look at this. This value I know. This is 300. This is minus 400. This is 300. This is minus 400. And now I use this information here. At theta is 30 degrees. Theta is 30 degrees. The value is minus 100. See that? Put the equation here. Minus 100 is the value at 30 degrees. 30 degrees, put it there. So I put it here. 300 minus 400 over 2 plus 300 minus 400 plus over 2 and then cos 2 theta. I know the theta is 30 degrees. Theta is positive 30 degrees. The value is minus 100. So minus 100 at theta positive 30 degrees. 30 degrees, 2 times 30, 60. And then plus gamma is y over 2 sine 60. Are you with me, guys?
Yes.
So what do we solve here?
Gamma XY over 2.
Yeah, this is how you solve your gamma XY. Everybody, are you with me?
Yes.
Yes.
This is how you solve gamma XY. You must have 3 gauge value. This is the easiest one. Why? You have one equation, one unknown. Correct?
Correct.
Okay. What about this one? What about this one? I don't have any x. 400 this is straightness is there. 10 degrees, 30 degrees. And my EA there is equal to positive 150. X is there, I don't have any. I have EA, I have EB, I have EC there. So for this case, which one do I know?
EY.
Yeah, I got EY. I got EX, I don't know. I got EY, I don't know. Minus 400. I don't know gamma XY over 2. Correct?
Correct.
Yeah.
Yes. So how do you solve this one? I use this information. One equation from here, one equation from there. So, this is theta 1. Theta 1 here. Theta 2 here. So, for theta 1 is equal to positive minus 10 degrees. EA is equal to positive 150. Write that equation. The other one is what? At theta 2 is equal to positive 30 degrees. EB is equal to minus 100. Write that equation. Are you with me, guys?
Yes.
Okay, write that equation. So what do we write there? Exactly, slowly. What is that? That value Ex, remember that? E theta is equal to Ex plus Ey. That equation, okay? E theta is equal to Ex plus Ey over 2 plus Ex minus Ey over 2 cos 2 theta plus gamma is y sin 2 theta. Ah, okay. That equation, write it back. Write the value there. Minus 150 is equal to Ex, I don't know. Ey, I know. Minus 400 over 2 plus Ex, I don't know. Minus plus 400 over 2. I know the angle. Angle is 2 times 10, minus 10. So cos minus 20. And then plus gamma is y over 2 sine minus 20. So from here, I don't know two unknown. Ex and gamma is y. So the total unknown is 2. Ex gamma is y. That's one equation. The other one is this. What do I write here? This is positive 150. Positive 150 here. That is minus 100. So this is minus 100. Minus 100 is equal to Ex minus 400 divided by 2 plus Ex plus 400 divided by 2 cos, be careful this angle. This angle is 30. 2 times 30, 60. Yeah? And then plus gamma is y over 2 sine 60. So I have two equations. One equation, two equations. How many unknown there?
2 unknown.
Two unknown. What is that? Ex and gamma x. Y. Are you with me?
Yes.
Okay. So this is the second hardest. The easiest one is what? The easiest one is, yeah, this one is in x direction. So this is in x direction, so one unknown only. So what if, can we have three unknown?
Can.
Three equation, three unknown, yes? What is the example? The example, three equation, three unknown is what? I don't have x and y, I don't have gamma is y. So I have a string here, this x, y, and then I have a string here, this 20 degrees, this 30 degrees, and then I have a string here. So let's say this is 60 there. So there's another 20 degree there. So everything is not XY. So EA there, EB there, EC there. So let's say the value here is minus 100. This is positive 200. So EC here is minus 300. Let's see. So remember, our angle is always from where?
From x-axis.
Yes, remember. This is your reference. Theta 1 is there. Negative 20. Theta 2 is there. Positive 30. Theta 3 is there. What's the angle there?
Positive 110.
Yes. Be careful that. Only then you write the equation. So what are the equation there? The equation must solve three equation. Three unknown, three equation. So what are the equation there? Put the first equation there. E theta 1. Okay, what is that the value there? Minus 100 is equal to Ex plus Ey over 2 plus Ex minus Ey over 2 cos 2 times negative 20, negative 40. Then plus gamma is y over 2 sine negative 40. One equation there. For E theta 2, write the equation. What do we have there? Yeah. Positive 200. Positive 200 is equal to Ex plus Ey over 2 plus Ex minus Ey over 2 cos. Be careful. The angle here is 30 here. Positive 30. And then times 2. 60 now. Yeah, plus gamma xy over 2 sine 60. So second equation. The third equation, E theta 3. What do we have there? Here. Minus 300 is equal to EX plus EY over 2 plus EX minus EY over 2 cos 110. From here to here is 110 times 2, 220 plus gamma xy over 2 sine 220. So 1, 2, 3 equation. In that equation, how many unknown? 3. What is that? EX, EY, gamma xy over 2. Are you with me, guys?
Yes.
So this is the things that we should understand. This is the topic. How do we calculate gamma? We must find the gamma first. Only after that we can do the analysis. Last week we have done the analysis, right? Monday. We have done the analysis from the equation, right?
Last week.
Oh, last week. Yeah. But we just take for granted gamma xy, right?
Yes.
Actually, we don't know how to calculate, how to get the value of gamma just being given to you and then you use the equation. So the gamma is actually from, you solve the equation from the measuring the strain gauge. Strain gauge is only give the normal strain, not the shear strain. We solve the shear strain by solving the equation. Are you with me, guys?
Yes.
Very clear not?
Very clear.
The easiest one is one unknown, one equation, right?
Yes.
One equation, one unknown. And then we have 2 equations, 2 unknown, right?
Yes.
And then we have 3 equations, 3 unknown, right?
Yes.
Yes. Okay. Shortcut. The maximum you don't use 3 equations, 3 unknown. Take a very long work. We can at least 2 equations, 2 unknown. So how do we do that? How do we do that? Let's say we have this. Okay. Look this carefully. Okay. I got EA there. So I have EX. Got. I don't have EY. I don't have gamma xy over 2, right? Are you with me?
Yes.
So if I use this xy like that, I have to solve 2 equations, 2 unknown, right?
Yes.
So what if I don't care about xy? Because this is 90 degrees then. Are you with me?
Yes.
That is 90 degrees. What is I change? This is my x. This is my y. So, as if, this is like that. This is my B, this is my C, my A is 30 degrees down there. This is my A. A. You see that?
Yes, can see.
You rotate that one, become like that, right? So B and C is 90 degrees, but you don't do this diagram, confuse you. So what you do, this is your reference now. Don't name it XY, because X is already there. Don't name in XY. Name it B and C. So your equation now, your reference is B. So your equation now is what? Not XY. E theta is equal to EB plus EC over 2 plus EB minus EC over 2 cos 2 theta plus gamma BC over 2 sin 2 theta. So you start with axis B and C. So your reference is now here. Your angle is from that one, not from X anymore. Can you do the analysis with B and C?
Can.
Can? So how many unknown here?
One unknown.
One unknown, because I want to find, I know my EB, I know my EC, I want to find gamma B and C over 2, right?
Yes.
How do I find this one? By that angle. E theta is equal to minus 30 degrees. At that angle, I know that value. So that value is 100 is equal to, my B is what? My B is 300. This is E theta. Here, 100 microstrain, 300 and minus 200. Minus 200 divided by 2 and then plus 300 minus plus 200 divided by 2 cos 2 theta, cos 2 theta. What's the angle there? Minus 30 degrees, 60 degrees, cos minus 60, and then gamma is y, not SY, gamma BC over 2, sine 60 degrees, sine minus 60 degrees. Can you see that equation there?
Can see.
Yeah. This is, you know this one, you know this one, you want to solve this one by that equation. So you solve gamma B and C. So you are plotting the Mohr circle. We don't use Mohr circle today. Tomorrow we learn about Mohr circle. Today I want to find gamma SY over 2 or gamma BC over 2, gamma CDY. At least X and Y is 90 degrees. B and C is 90 degrees. Anything 90 degree, you can set axis, make you much easier. So you solve one equation, one unknown. If you use XY, in this case, you know only X. I don't know why, I don't know gamma is Y. You have to solve two equations there. Here, you use B and C, you use one equation only to solve gamma. And then you can find back. When you rotate back, when you know gamma X, B, C, you can plot Mohr circle, you can use the equation, you can find EY, you can find not? Yes. From that axis to that is 60 degrees, you can find that. The value from B here to that value, you can find Y not? Yes. Are you with me, guys?
Yes.
So that's our topic for today. Okay, are you with me?
Yes.
Yes, doctor.
So I want you to do those exercise tonight. Today, this afternoon, do this exercise very quick. Some of them can use XY. Some of them can use BC or CD, whatever you name in the direction. As long as it is 90 degrees. And then when you finish, can you find the other value? Yes. Okay, clear, guys?
Clear.
Before that, what is the basic concept?
What's the basic concept?
What is the basic concept?
Questions. Ask.
Yeah, the question, not the basic concept today, what is that?
Strain gauge.
String.
The gamma is being derived from
Done.
equation. We can only measure the normal strain
Strain.
by calibration the voltage, current. Are you with me? The same with your weighing scale. Timbang. Pergi ke kedai tu tengok weighing scale, electronic scale tu semua pakai strain gauge ni. Calibrate the resistance that one, current to the kilogram. The same with it. Calibrate that current resistance that one to the strain. Only then you can measure the strain. Okay, clear?
Clear.
Okay. Okay, Assalamualaikum. I give you exercise for today. Okay, thank you. Assalamualaikum.
Thank you, doctor.
Thank you, doctor.
Thank you, doctor.
Okay.